Yesterday we have done a small chapter, that is force, correct? Today let us try to do another interesting chapter, that is friction. Write down heading friction. Friction. Write down heading. Completed? Okay. So what is this man trying to do? Tell me, what is this man trying to do? Yeah, he's trying to pull a box. Now you have to tell me whether it is easy or tough. Okay. This is not a matchbox, it's a big box. Okay. Okay. Look at this. Now here you can see a man cycling. Correct? He has to continuously pedal. So why he has to continuously pedal? Look at this. When he stopped pedaling, a bicycle, it gradually slows down and finally comes to a stop. Next. This boy is kicking this football. So no force appears to be acting on the ball, yet the speed gradually decreases and it comes to rest after some time. The force responsible for changing the state of motion of the ball is called as the force of friction. Then we have seen yesterday two types of force: contact force and non-contact force. In contact force we have seen muscular and frictional, right? So we are going to see frictional force in detail today here. So we have friction force. Whenever an object moves or tends to move over the surface of another object, there is a force acting between the two surfaces in contact. Okay, look at this force of friction. This boy is trying to push this box. This is called as displacement. Okay, the box has moved from certain distance and the friction is acting in the opposite direction. Do you understand? Look at this. Okay, so force of friction always acts on the moving object and the direction is always to the opposite direction of the motion. Okay, now look at this. I'll do a small experiment. You have to tell me what is happening here. I have kept some books and I have kept a plank and I'm going to keep a small toy car here. Imagine this is the inclined plane. Okay, the plane is it at a certain angle and this is the car. Imagine a toy car. Okay, the car has traveled certain distance, right? But it stops after traveling certain distance. What if I want to increase this distance? What if I want to make this car travel more distance? What will I do? Yes. So here the distance, due to the force of friction on the wooden surface, the car comes to rest. When the car is coming down, it is little faster. But here the wood surface and the tire, they have a friction and the car stops gradually. Okay, now look at this. What if I keep a smooth surface? Imagine I keep a tablecloth and now I keep a car here. Again with the same speed the car travels and now okay there is again the stoppage of this car. So now this is how the friction works in daily life. Do you understand? So look at this. In the first case, the distance of the car, where do you think the car covered a greater distance? In the first case. Okay, look at this now. Why did this happen? The roughness of the surface in contact. Do you understand? Next, force of friction depends on the nature of the two surfaces in contact. So there are two surfaces. Roughness decreases, the force of friction decreases. Roughness increases, the force of friction increases. So all surfaces have same roughness on them. Imagine This man is trying to push this box. Okay, there is a smooth surface. He's trying to push this box. Still the block comes to rest. Why is it that? Look at this. Here, this is the surface of the box and this is the surface of the floor. Okay, so here you can see there is some interlockings. Okay, so this interlocking is the responsible for friction. Do you understand? You cannot see with your naked eyes, but if you see with the microscope or something, you can see the roughness. This is called as roughness of the surface. So when two surfaces are put in contact, the irregularities of one surface get somewhat interlocked with the irregularities of the other surface. Force is applied, but that force is not able to set the body in motion. Let us understand why. Look at this. I'm applying force, but sometimes the body does not move. Okay, look at this. So here I have a block and I have a rope tied to it. Now I am going to do an experiment. This is called as block. Okay. Next, this is called as the spring balance. Okay, let me see an example. Everyone knows there is a force called as gravitation force. Okay. What is the gravitation of the moon compared to Earth? Yeah, it is one sixth of the Earth gravitation. Okay. So now the question in your exam was: suppose if I take suppose if I take 1 kg weight and if I take a spring balance, I go to moon. Okay, 1 kg weight I go to moon, I take a spring balance. Now I measure it. What will be the deflection showed on the spring balance? Hmm. Because of gravity? Okay, what will be the readings? Okay, the options are like this: 40, 60, 100, all of the above. Or no change. Imagine, let us say no change. Okay, once again I'll repeat the question. The gravitation of the moon is one-sixth of the gravitation of the earth. Did you all understand? This is the universal truth. There is no change in that. Now I take 1 kg of some weight. I go to the moon. I take the spring balance and I measure it. What will be the reading showed on the spring balance? That is the question. Okay, now the options are 40 kg, 40 grams, 60 grams, no change, or none of the above. Hmm. Okay, the answer is it will show no change. It will show 1 kg only. Do you understand? Because it is spring balance. Do you understand what is the meaning of mass and weight? समझ में आया? So that logic you should do it. So try to look at this now. I'll explain that once again. But right now just look at this. This is the spring balance. This is the pointer. Okay, and this pointer is at 0 now. I'm going to pull this spring balance back. Okay, this is the block. So look at this. What happens? This is the spring balance. So this is the reading. I'm going to pull this spring balance back. Okay, I'm pulling it back. So when I'm applying the force, I'm applying the force, but the block is moving or it is not moving. Is it moving or not moving? Not moving. Okay, so this is your observation. Look at this now. Next. The reading of the spring balance changes, but the block does not move. The reading was 0, now it is 40. I am applying force, but there is no work done. You understand? I am applying force, but there is no work done. So something is stopping this block. Okay, something is stopping this block. Let us see now what is next. Look at this now. The reading gives the measure of the force of friction between the block and the wooden surface. So this reading 0 to 40, this is the reading of friction force. Which force here? Friction. So what is the friction between the block and the floor? It is 40. Okay, 40 units. Now look at this. Now I try to pull it. So beyond 40 when I pull the spring balance, what happens to this block? The block will also move. So I require minimum 40 Newton or anything force to move this block. Do you understand? Okay, so this is what is the logic of friction. Now imagine I am keeping two blocks here. Okay, I am keeping two blocks here. Let us do the same experiment. So you have blocks here and the reading is 0. Okay, now how much it would be? 80. So what do you understand from this? When you apply 80 force, the block is still not moving. So if I apply more than 80, the block will move. So what is this 0 to 80? This is nothing but the friction force. Okay, this is called as the friction force. Do you all understand? Okay. So now, yes, that's it. This is the experiment which we want to prove it. This is the spring balance. Spring balance looks like this. The 0 reading is here, 0, 20, 40, 60 till 120. Okay. Next, spring balance is a simple device that can be used for measuring the force acting on an object. It consists of a coiled spring which gets stretched when a force is applied to it. So here this is the ring. Okay, stretching of the spring is measured by a pointer and this is the graduated scale. So this is the ring. This will be, in your finger or somewhere on the nail, and inside this there will be a spring and these are the readings. There will be a pointer, red color or any other color. Okay, so the SI unit of a force is how much? 1 Newton. Okay, so the force is said to be 1 Newton if it produces an acceleration of 1 meter per second square of 1 mass, 1 kg mass, and this is the hook. Factors affecting friction: nature of the two surfaces in contact, force pressing the two surfaces together. Now let us try to understand types of friction. Static friction. Okay, so this is an experiment. Imagine a boy is trying to push this box. Direction of the force. See, look at this. The boy is trying to push this box towards your left. Correct? And where will be the frictional force? In the opposite direction. Okay, so what do we find here? This force is not sufficient, so he's going to apply more force. Okay, suppose if he applies more force, the box will move. Okay, so when an external force acts on the box, the force of friction acting is known as the static friction. This static friction balances the force which we exert on the box and the box remains at rest. Now imagine he is applying force once again. Okay, this is the 2 Newton. Force of friction, it is equal 2 Newton. Again, there is no movement. So this is also not sufficient. Why does this happen? Because the force of friction is equal to the force applied here. Okay, so now look at this. Force of static friction increases of the applied force. Static friction is self-adjusting force. So this is the idea you have to keep in mind. Next you have sliding friction. Look at this. This is the direction of the force. Okay, now I'm going to push it with more force. Now it slides. Okay, now it slides. So this force of friction is known as sliding friction. Just remember this point. The force required to keep the object moving with the same speed is measured of sliding friction. Next, this is an experiment, sliding friction experiment. Look at this. Here there is a block. Here there is a tray, and in this tray I am going to put some weight. Okay, I am doing experiment of sliding. So this block is going to slide on this table. Do you all understand? This is the table, and on this table this block is going to slide. But when it will slide, tell me? Yeah, in this pan what should I do? I should remove the weights or add weights? Okay, shall we do that experiment now? Look at this. So this is the block. Okay, when some weight is added to the pan, look at this. I'm going to add. I added the one weight here. It is not moving. Okay, again I add some more, and now the block moved. You understand? So this is called as sliding friction. Okay, it has to continuously move. This continuous movement is called as what? Sliding friction. Okay, now imagine graph for friction. This is x-axis and y-axis. Applied force and force of friction. It is always a straight line from the origin. Okay, so it can increase only up to a certain limit and then it falls down, limiting friction, and then this is called as sliding friction. So initially you have to overcome the static friction, then it stops, then gradually it falls, then sliding friction is continuous. So this is the graph of the force here. Okay, next. So why is sliding friction less than that static friction? Look at this. This is the surface of the box and surface of the floor. When I push this box, this is interlocking. This interlocking makes it very difficult for the box to move. This is called a static friction. But once if this box start moving, then it will be very easy to overcome. There is no interlocking. Do you understand? Okay, look at this now. Once the interlocking have unlocked, the block starts moving. Okay, so when you are pushing it, there is no interlocking. It becomes smooth. So once the motion starts, the contact points on one surface do not get enough time to lock into the contact points of the other surfaces. Next, we'll see rolling friction. Okay, have you seen this kind of trolleys in your home? Correct. So why do we have wheels here? Yes, to reduce the friction. Okay, so why do we have the wheels there? It makes easy for the person to pull the bag, thus reducing the friction. Such a friction is called as rolling friction. Now let us try to do this experiment. Look at this. I'm going to take the same block, and now what I have done here, under the block what I have kept? Pencils. Okay, and now this is the pan here. So I'm going to put some weight here, imagine. So this is the block. So when some weight is added to the pan, look at this. Now I add some weight to the pan. It's not moving. I add some more weight here. Now let me see whether it moves. Yes, it moved. Okay, so what happens? Rolling friction is, compared to sliding friction, rolling friction is much lesser. Correct? So look at this. The force of friction that comes into play when one body rolls over the other surface is called as the rolling friction. So now look at this, is important point. Static friction exists between two surfaces in contact, between which there is no relative motion. Next, sliding friction, it exists between two objects when one of them is sliding over the surface of the other. And rolling friction, it exists between two objects when one of them is rolling over the other. That's it. So always remember this line. See, in exam they will ask you these things in exams. Take it now. Which is the largest friction here? Large amount of force required? Static friction. Least amount? Rolling. And what is the middle one? Sliding. Static is greater than, sliding is greater than rolling. Now they may ask you in reverse direction. Rolling is lesser than sliding, and which is lesser than static. That's it. If you don't understand what was done in the previous slides, but at least you should know this line. Okay, they may ask you this in exam. Okay, what is this? Tire. Why there is gap like this in this? Why there is gap like this or designs like this on tire? Yes, for the purpose of the grip. How many of you gone to Wonderla? How many of you played that dash car is there? No, you have to, yeah. Have you ever seen that tire? Yeah, उसके नीचे okay, yeah, yeah. Actually उसके नीचे जो टायर रहता है ना वो स्मूथ होता है, वो ऐसे ग्रिप वाला नहीं होता है, ठीक है? Yeah, we'll see this now. Look at this. The wheel has been considered as one of the greatest invention of the history of mankind. Okay. So when do you think the force friction to pull the bag will be less? Okay, now look at this. There are two persons. They are doing to do. They are going to do some work. One is trying to pull this bag, and one is trying to push this bag. Which is easy? This is easy. Why? Tell me. Because there is a wheel and there is rolling friction. Correct. So this A will be little easy. Okay, he will find little easy to do the work. Okay. Now next, look at this. Yes. Yes, we'll see that necessity or evil, friction is good or friction is bad. Okay, look at this. It is a necessity or is it evil? It is a necessary evil. Look at this. Why do we require friction walking on the ground? If there is no friction, you cannot walk on the ground. Do you all understand? That is why the question in your examination is like this. How will you move on a ground which is very smooth? There is no friction on the between your legs on the ground. I explained to you. Yeah, what was the answer? Yes, you can jump high and then you can move in any direction. So walking on the ground requires friction. Okay, so look at this. Your shoes, see, look at this. This is your leg. Okay, this toes is trying to push the grass, and in opposite direction there is friction. That is why you are able to move. Okay, next. So we have seen it is a friction between the ground and our feet that enable us to walk. When we walk, we push the ground and our feet in the backward direction. Friction then provides the forward reaction and makes us move forward. If friction between our feet and ground were absent, it would be impossible to walk. So the first necessity, friction is necessary. We have seen one point, that is walking on the ground. Next is for rolling. Okay, what is this? Cycle. So to have rolling friction, you need to, rolling kind of force, you need to have little bit of friction so that the object moves. Okay. So the same thing here, same story once again. You can read this later when you are free. So the friction becomes less when a specified value, the wheel tire can lose their grip of the road. Next, performing small day-to-day activities. Now, for example, what are the day-to-day activities you do? Writing with a pen or pencil on the paper. It is possible only when there is a friction. Okay, so when you write with pen and paper, correct? Next, let us try to understand now evil. Okay, is it a good thing or a bad thing? Now we'll talk about the bad thing. Loss of energy. Friction consumes a substantial part of the useful energy available to us. As friction opposes motion between two objects in contact, some of the energy to move the object is wasted. Look at this. This is car and now it is moving. So when it moves, you can see the engine gets heated. Yes or no? So what happens? There is a friction between all the engine parts and that friction is loss of energy. Okay, that loss of energy is resulting in forming the wear and tear of the vehicle. That's why you have to do service and all. Okay, so the major part is wasted in heating the machine. Friction between the ground and tires and sounds are produced. Okay, next, look at this. Wear and tear of objects. Okay, wear and tear of objects. Now imagine, let us try to understand. This is a new tire, this is an old tire. Can you see the difference? So why this old tire has become like this? Because of friction. Okay, because of friction, this there is wear and tear. Okay, the tire gets damaged and every time you have to bring something new. Okay, look at this now. So these are the pros and cons of friction. Methods of increasing friction. Whenever friction is required, it is increased by making the surface rough like this. When I require more friction, imagine this is the tractor tire. Okay, so the tractor tire has this kind of treads. This is called as treads. Treads. Okay, next, shoes. Have you seen athlete shoes like this? Okay, why do they have like this? Yes, sportsmen and the players use special types of sports like spikes on the sole. This helps them to have a better grip on the running. Okay, when they run. Next, methods of reducing friction. How should I reduce the friction? Polishing. Correct. So I can polish the surfaces, make it smooth. So when I make it smooth, the sharp surfaces, like I have told you two surfaces they interlock with each other, that will be reduced. Okay, next, lubrication. Okay, now you apply grease or oil in your day-to-day engineering components. This is to reduce the friction. Now let us see. Bicycle and motor vehicle mechanics use grease between the moving parts of these machines. Okay, have you done this kind of things for your cycle? Okay, now let us see some more important. Okay, lubricants can be liquid or oils. Next, semi-liquids like grease, solids like talcum powder. Tell me, where do I use talcum powder? Yes, carom board. While playing carom board, the striker moves very smooth if these powders are applied, so it reduces the friction. Okay, what is this? Yes, this is called as bearings. So this slide is very important. Those who are not having an idea of how your wheel or handle or anything rotates. Dekho, can you see this in center? Okay, this is called as bearings. Actually this is completely called as bearing. Now there are different kind of bearing. Look at this how it functions. Okay, ball bearings. Can you see this here, small balls here? Okay, on the right side here. So this will reduce the friction. So this is there in your wheel. Okay, this is there in your wheel of cycle or bike or any other. Yes. So rolling friction is smaller than sliding friction. Sliding can be replaced by rolling in most machines by use of ball bearings. We use ball bearings in shafts of motors, dynamos, axles of vehicles, etc. Fluid frictions. Whenever an object moves over the surface of another object, frictional force, solid friction comes to play. Okay. But what happens when an object moves through air? Yesterday we were talking about fluids. Air is a fluid, true or false? True or false? Water is a fluid, true or false? Milk is a fluid, true or false? True. Okay, so anything which flows is fluid. So now what happens with air? The air also exerts a force of friction even though it is very light and thin. Many years ago, there was one Indian lady called as Kalpana Chawla. Have you heard that lady's name? Okay, what happened with her life? Yes, Columbia Space Shuttle. Yes, while returning to Earth, what happened to that shuttle? Yes, very good boy. So when the shuttle was entering inside the Earth atmosphere, there was friction and there was fire in the Columbian space shuttle. Okay, so look at this. We call this friction as the air resistance, and it also opposes the motion of objects. See, this we are doing from a science perspective, but the exam questions can be from geography perspective also. The questions can be like this: why some meteors don't reach the Earth? Okay, they come from the space. When they enter the Earth atmosphere, they burn in space itself. Okay, yes, they evaporate due to high resistance and fire temperature. Okay, look at this. Let us do some activity to understand. I have a paper sheet like this here on the ceiling, and I have another paper which is crumbled here. I make it a small ball kind of thing, and now what I do, I drop it. I drop this both at the same time. Which one will come faster down? Yeah, this one will come faster down, correct? Yes. So drop both of them at the same time. So what happens here? One comes faster and one comes slower. So why it happened like this? Yes, the crumble sheet come faster because of the resistance of the air. So air resistance acts to the direction opposite to the direction of motion of the paper. Okay, so factors affecting force of fluid frictions. Nature of the fluid, shape of the moving object, speed of the moving object. Now look at this one by one. What is this? Aeroplane. Why this aeroplane is this shape? This is aeroplane. Next, what is this? Yes, this is ship. Okay, next. Where do you think the shapes of these machines got inspired from? We invented aeroplane. Who invented aeroplane? Tell me. Wright brothers. Who are those Wright brothers? Yes, Oliver and William Wright. Okay, in which place did they invented this? No, America is correct, but in America, which place? No, 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 not California. Answer is Detroit. Okay, remember one thing, Detroit is famous for all the automobiles. So now the question in GD examination, general duty and all this examination will be like, which place in India is called as Detroit of India? Which place in India is called as Detroit of India? Answer is Chennai. What is that? Chennai. Now tell me what is famous in Detroit? Manufacturing of automobiles. So what will be famous in Chennai? Manufacturing of automobiles. Okay, so remember this. So we got inspiration from birds, okay, and then we got inspiration from fish, okay, in order to design this. Now look at this. What is this? Formula F1 race car, right? Okay, so tell me some of the Indian Formula race car yeah, Indian Formula One race cars drivers. Narayan Karthikeyan. Okay, international players. Lewis Hamilton. Then yes, we have done. Last class we have done it. Look at this. Now, why this body is like this? See, one more thing. Look at this. In future, if you want to buy a car or something, be careful. Try to apply a little bit of common sense. Look at this. The ground clearance, you can see, is it more or very less? Very less. If the ground clearance is very less, the object will not fly from the ground. It will be, the air will come, hit on this surface, and it will go up, it will not go down. But if you see on the road in highways, when next time when you travel on highways, you can see Mahindra Scorpio or Bolero, or otherwise the truck, okay, the big trucks and bus will be overturned. Why? Because the gap between the surface here, this surface and the ground surface is large. So the air is moving down, and if the air is more and the speed of the body is more, it becomes a object which flies, and that's why there is an accident in turning and all those places. Okay. If I want to take class, aerodynamic class with this F1 car race, it will take another half an hour. Why this wheel is wider? Okay, why this object is little smaller? Why this man here he's sitting in this position? Okay, we'll see that in slowly in upper like higher level physics classes. Right now, just see what is happening here. The sports vehicles are designed that the air flows smoothly over their surface. This is called as streamlined bodies. Okay, so nature gives us some useful ideas to the mankind. Streamlined flow of air helps to reduce the friction of air and helps them to acquire a faster speed. Do you all understand? Yes. So do you all understand the topic of friction here? That's it. Switch on the lights now, quick. Switch on the lights. Yeah, start writing whatever you understood. Let me